very difficult. We send one signal and we get multiple signals. And these signals interfere with themselves and they interfere with somebody else and they make lots of damage. That's the main problem. If we were using wires, we send one signal, we get one signal. In wireless, that's not the case. The default case is you send one signal and you get multiple signals. What is the implication? So what's the problem? Well, it means I can send 1 milliwatt and the signal, because of these copies trying to interfere with each other, they can go all the way to 1 microwatt. So I have to design my system to deal with a wide range of powers. The nominal value is 1 milliwatt, but it should be able to deal with signals 1,000 times lower. And this is, people who are working in hardware, they know this is very difficult. Use a system that has this extreme wide range of operation. You want to deal with 1 watt, but sometimes the signal goes to 1 microwatt and you still want to be able to use it. And that's very tough. So this is multipath. Now, we said that it's very problematic, we have lots of problems, yes, but there are solutions. And solutions are based on tricks, neat tricks usually, neat technology tricks, and innovative ideas. Usually, the moment an engineer finds some of these tricks and innovative ideas, the first thing he does is write a patent about it and protect it. If he is more courageous, he could set up a small company and try to do his own modem design or his own system. If he is a bit more clever and energetic, he gets bought later on by a company like Cisco or Broadcom or any other company. This is how companies, little companies, were frequently bought in the period around 2000 to 2005. Hundreds of companies established by students, mainly graduate students and PhDs, recent PhDs. They come up with simple solutions like this, tricks. They patent them. And after they patent them, they set up a small company. And they start selling the idea. Now big companies like Cisco and Broadcom and Nortel and Bell Labs and all the AT&T Wireless, they hear about the solutions, they don't want to pay royalties for the patents, they go and buy the company. That's the way it works. So the solutions exist, and they are there. Let's go a little bit more now into how the service is provided. How do you provide service? How does the network provide me service? Now there is a base station, and the network is providing me service. Now we have 2 paths. We have one path from the station to me, and from the mobile to the station. And we call this duplexing. Duplexing. We have 2 paths. We have to duplex the 2 paths. We either do it in the time domain, and we call this time division duplexing, or we do it in the frequency domain. If we do it in the time domain, I will give you one turn to talk to me, and then in the second turn I will talk to you. That's time duplexing. And the other one is frequency division duplexing, and I will use the band, the frequency band. You use your own band, and I use my own band. But we can be talking at the same time, since we are all using our own. All the communication systems that we deal with belong to one of the 2. So it's either FDD or EDD. This tells how the system talks to the mobile or the mobile talks to the system. Another thing that we need, how do multiple mobiles talk to the system? Multiple mobiles now, they need to talk to the system. We call this multiple access. This is multiple access. Multiple mobiles, they want to talk to the system. Until when you make a phone call, you don't wait until everybody are done with their phone calls. You make your own phone call, and others are also doing their phone calls. So the system can handle multiple calls coming from the audience. This is the way it was done in the 50s and 60s. Everything was analog at that time. So we use the band, the frequency band, to distinguish between the users. Every user has his own band in the frequency domain. They look very neat and separated, and the system will identify them by their position on the frequency band. Very simple. This was the origin of all communication. So that's why I wrote here, it's old analog networks. This is what it was before. But in the 80s, people started to use digitization. And everything became digital, and everybody was happy about the digital revolution. It means all sources of information can now be converted to bits. Now, if I can convert them to bits, it means I can store them in memory and send them whenever I want. And that's exactly what is happening in your GSM phone right now, or any other phone. Your voice is converted to bits. It's stored in the memory on the phone, and then the phone and the network decide when to exchange these bits. And we call this time division multiple access. Why? Because I will give you a certain slot in time. When your turn comes, you send your data. And then after your data is done, the other phone data will come. And then the third phone data will come, and so on. So we are dividing the resource in the time domain. Okay? This is called time division multiple access. In the 90s, people were very enthusiastic about a third new technology called spread spectrum or code division multiple access. We will allow users to talk simultaneously on the same band, but we will give them a secret key. Each one of them will use his own key in the communication. So this was very new, by the way. This came from the military side, because the military people were very interested in these kind of jamming and hiding signals and all these things. So this concept came from there. We will use the same band all the time by all the users. So the signal will look like really a mess. But everyone is using his own secret key. And the system will use the keys to distinguish between the users. And that's why we call this code division multiple access. And people were thinking in the 90s that this would be the future for communication. We're using the entire band all the time, maximum utilization. But we're separating them in terms of the keys. And yes, it was very hot at that time, in the 90s. Maybe until the early 2000s. Now, with this have said about this introduction, let's see how did the systems evolve. I will not go into the technical details a lot, and I will only focus on the current and future. I will just mention briefly about the past. I'm focusing on wireless wide area networks, as I said. So these networks are designed to cover countries and a huge area. And they usually allow very good support for mobility. You can be in your car, you can be walking, you can be in home, and it allows you to roam around. You don't have to stay in one place. So you can move from to different places. And usually what we do is we use the concept of a cell. If STC wants to cover Sharqiyya, then they have to divide the Sharqiyya into cells, and they put a site in every cell. Okay? So usually there is a wireless operator that is involved. Like in our case, we know that STC is involved, we know that mobile will be involved, or any other wireless provider. Now, initially these systems that are wide area networks, they were voice oriented. When they were designed and optimized to service voice. Because voice was the main source of income. They charge you by the minute. If you talk, you pay 90 harar for every minute that you use our network. So everything in the network, in terms of resources, bandwidth, is optimized for voice. But as the internet started to become very, go into our lives, even kids now want internet access at home, and they have their own laptops and notebooks and things like that. Internet became very important. Now people started using it. Now these operators who are providing voice, they started to add a little modification to the voice system to support data.